Hello, we are from the group number 4, and today I would like to talk about our project. Our project is topic the problematic soft soil and ground improvement. This our group member is number 1 is me, Muhammad Noifan bin Abakar, and number 2 Muhammad Kamil bin Abdul Rahim, number 3 Fatin Samira binti Abdul Aziz, and number 4 Muhammad Rafiq Fikri bin Romili, and lastly Siti Nordiana binti Buang. Okay, next I will like to talk about the introduction. Okay, first after consolidation, hypothesis and investigation procedure are determined, the next step in the planning circle is to obtain soil boundary for condition of all PC programming. The technical engineering biggest challenge is ensuring soil boundary. From one perspective, each soil characteristic need an incentive. Few soil properties are constant, and the solidification coefficient is stable, and the combination coefficient for fragile soil is inconsistent. Its worth is determined by many factors, including the excessive combination properties, pressure expressed, soil texture, and the assurance method. Holz and Covert 1981. In some circumstances, design judgment is needed to determine the higher value. Great design judgment comes from understanding soil behavior and previous experience with a similar soil and geotechnic concern. Alright, permeability is another vertical channel limit. Pronas coefficient is one of the most difficult soil boundaries to resolve, and permeability is the most variable soil characteristic. Its worth can change from the 10 to 11 ms from the soft clay to 10 to 3 ms from the sand and rock. Despite the low proneness of soil be treated with vertical channel, permeability is assessment error may be 10 to multiple times. This is not surprising because its soil porosity might influence during the union cycle.
Assalamualaikum and hi, I'm Fatin Shamira. Will continue with the case study for our project. We choose the building of Polytechnic Kota Kinabalu, which is in Sabah, as our case that related to our topic, which is problematic of soft soil. The construction of this structure began in 1999 and was finished in 2003. The construction site is located on a low-lying area in order to access the planned platform which needed substantial earthwork. The teaching restaurant and core service building, two of the campus main structure, were subsequently to have structural cracks. The irrigation infrastructure, including perimeter drains, had already suffered significant settling. Geotechnical investigation toward problems. Kumpulan Ikram Sabah was here to do a geotechnical audit on a problematic structure in November 2004. The discussion in this section is based on subsoil profile, settlement analysis and monitoring, piling records, and pilot tests. First is subsoil profile. This shows the cross-section of borehole profile. The result of borehole reveals the presence of fill material in the thickness of around 7.2 meter at the location. The layer is underlain by 10.6 meter of clear sandy silt with some organic materials that is very soft. At a depth of around 18 meters to 20 meters measured from the ground level. A hard-weathered siltstone and extremely poor weak sandstone were identified. Next is settlement analysis and monitoring. The investigation team performed back analysis to determine the amount and rate of the consideration process at the location. According to the result from September to December 2005, A total ground settlement about 130 mm was observed, corresponding to 103 mm per year. A targeted 19% degree of consolidation is expected to be achieved between 9 to 13 years depending on the actual thickness of the soft compressible layer and height of fill at the site. Column settlement monitoring records reveal that the columns of the core facilities building settle at different rates. As a result, differential settlement on the base of the structure is probably the main source of the crack. Next is piling record. The investigation team conducted a second review of the piling data in order to determine the real reasons of collapse. According to the summary of piling documents, 250 mm times 250 mm reinforced concrete square piles were used as the building foundation. Block A and Block B of core facilities building have average pile penetration depth. The piles were installed with a hydraulic hammer. A simple calculation based on dividing 300 mm penetration by total final blow counts reveal the piles may not properly set during installation. Pile driving records stated that the piles had achieved a set of 12 mm per 10 blows. Settlement monitoring on columns revealed that certain piles had been proven to be settled. Lastly is pile load test. The investigating team performed a pile capacity study using the available data. The geotechnical capacity of the proposed pile is considerably lower than the original design when negative skin friction is taken into account. Table to show the pile available bearing capacity of the location. The findings are consistent with a design elevation of original design. As a result of settling ground, the major sources of issues might be overloaded piles subjected to negative skin friction. This shows different settlement of the pile foundation resulting the building cracks.
Okay, next slide. Application to improve soft soil and groundwater. Based on the SI report, our case study at Polytechnic Kota Kinabalu for improving soft soil and groundwater, we recommend to use the vibro compaction method because quality assurance. Vibro compaction is a ground improvement technique and densify clean, cohesionless granular soft soil with a downhole vibrator. So next slide. We recommend to use the vibro compaction method because number one, reduce foundation settlement. Number two, increase bearing capacity, allowing reduction in foundation size or width or by foundation. Number three, increasing stiffness. Number four, increasing shear strength. Number five, reduce permeability. Number 6, mitigate potential for liquid function. Number 7, provide increasing slope stability. And number 8, permit shallow footing construction. And lastly, very effective for sand compaction and land reclamation. Okay. Okay, next slide.
My name is Siti Nordiana binti Buang with matrix number CF200220. So we move to the next slide, which is the application to improve soft soil and groundwater. So based on our case study, we have decided to use vibro compaction method as our method for the case study, which is we have agreed it is suitable for the building of Polytechnic Kota Kinabalu. So, vibro compaction is a technique to transfer structural loads to suitable levels in poor ground condition. So, it is a ground improvement technique for stabilizing granular soil such as loose sands, gravels, and some hydraulic fills. So, this method is primarily used for mitigation and in situ densification of loose sands, up to 30 meter in depth, which is able to shallow foundation to be built with bearing pressure up to 500 kilonewton meter. So this technique is commonly used to reduce foundation settlement, increase bearing capacity by allowing in footing size, increase the stiffness and shear strength, reduce permeability, and also provide slope stabilization. So the procedure for this vibro compaction method is: first, the vibrator is penetrated to the required design depth, assisted by water jetting from the nose cone. Next, upon reaching design depth, water jetting is reduced before the vibrator is slowly extracted with pauses at regular intervals to ensure that the satisfactory levels of compaction are achieved at each step. The vibrator is withdrawn back to the surface where a zone of compacted ground is formed around the insertion point. Additional side wound seam may also added at the top of the hole in order to fill the cone of depression that is formed. Lastly is the rate of attraction is varied to the soil to the suit of the condition encountered on site and to ensure that the correct amount of densification is achieved for each project. So lastly, the data from the system recorded from the in-cab monitor. We move to the next slide, which is the advantage of vibrocompaction method. First one is it can reduce the threat of liquefaction, such as the event of earthquake. Second, it is economical and sustainable. Third, it can be adjusted to a variety type of soil. Fourth, it saves the cost because it is only small quantity of soil that has to be removed during the process. And the last one is low vibration. So when it has a low vibration, so there will no any noise pollution happen on site. That is for me.
Assalamualaikum and greetings. My name is Muhammad Kamil bin Abdul Rahim, matrix number CF2001715. And today I'm going to conclude the presentation for our group project with the conclusion. Clay often causes difficulty in construction with its low strength and stiffness. It may cause damages to the foundation of building and crack along the road pavement. In order to solve this problem, cementous material can be used in order to stabilize the soil, such as the ordinary Portland cement, which is commonly used to solve this type of problem. That's all from us. Thank you.